Essentially, the James Webb Telescope provided the most precise image of Proxima B in history, uncovering stunning bits of knowledge into a possibly tenable exoplanet. It obliges us, as we set out on an excursion through space, to uncover the secrets of Proxima B and find out whether it could be the next Earth. We ought to take off into the vast expanse of space, where an unidentified planet exists in the star's habitable zone, Proxima Centauri. This planet is not just any ordinary rock, it's a reality. Proxima B is found a mere 42 light-years from us. This planet is covered in mysteries and wonders. Could there be another Earth, with seas and life blossoming on its surface? However, there is more. Proxima Centauri B isn't alone in that system. Around the red dwarf star, it has a companion, Proxima Centauri C. And what else? Additional mysteries that the galaxy holds. Maybe there's another companion that we haven't yet discovered. The secret doesn't stop there. Proxima Centauri produces approximately the same quantity of energy from its star as Earth does from the Sun. Could this truly mean that there may be water on its surface, even life? As we venture outside of our solar system, we encounter a new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander freely, unattached to any star, like travelers in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. With a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun, one side of the planet is constantly washed in sunlight, while the opposing side is always in darkness. Now, let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our solar system. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G-type and K-type stars appear in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf, or M-type star, discovered approximately 21 years after the other two stars. It is typically about 4 times as far from them. It is also the star closest to the Sun and Earth. Proxima, in fact, means the closest star in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. Although they don't produce a lot of energy, the internal processes of convection at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, indicating that it experiences frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 54 cents. But it's not as comfortable to live in as it appears. Intense bombardment of Proxima B by ultraviolet radiation from its star, frequently more powerful than the radiation we get from our Sun, is extreme. That's right. It's so intense that even the lightest particles of hydrogen are removed, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a vitally important, stable environment for controlling temperature and maintaining a water-friendly surface. Without that, life would be susceptible to harsh space weather conditions, making life nearly impossible. So, while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious, as there are numerous factors that make it inhospitable. The mission to reveal the truth about Proxima B continues. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope finally launched in 2018. It will help us determine if there is life on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure that the James Webb Telescope provides accurate representations. Abby Tabor, a Harvard theoretical physicist, said, "If a planet like Proxima B can, besides being able to absorb light from its star, transform it into infrared light, the James Webb Telescope was developed specifically to capture infrared light. It can detect light from the planet's surface and look for patterns that could prove the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life," cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere significantly denser than Earth's and extreme temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are additional costs to take into account. Mounting pressure is building for scientists to find ways to observe planets like Proxima B. They have a lot on the line, but the rewards are even greater. The opportunity to explore the unknown, to discover a distant planet's secrets that possess life-sustaining potential, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests that it might have life-sustaining conditions. Proxima B's proximity also makes it a perfect target in our search for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take a spacecraft 75,000 years to get to Proxima Centauri, similar to Voyager 2. Still, the Proxima Centauri system remains an option. Solar sails have been proposed for these missions. The use of extremely thin sails could propel an aircraft bound for the Alpha Centauri system and Proxima. This technology uses solar pressure to maintain its course. If solar sail missions become a reality, they could drastically reduce the travel time to Proxima Centauri from tens of thousands of years to just a few decades. Projects like Breakthrough Starshot envision sending tiny, lightweight probes propelled by powerful lasers from Earth. These probes could travel at up to 20% the speed of light, reaching Proxima Centauri in just over 20 years. But even with the technology in place, there are still countless engineering, communication, and durability challenges to solve. These probes would need to survive deep space radiation, maintain course without onboard propulsion, and successfully send data back across 4 light-years of space. Even the smallest error could render a decades-long mission useless. Despite the hurdles, the idea of exploring Proxima B continues to capture the imagination of scientists, engineers, and dreamers alike. What if we could send robotic explorers to land on its surface? What would they find? Rocky terrain, icy plains, stormy skies, or perhaps something completely unexpected? And what if the planet harbors microbial life, tiny, resilient organisms clinging to existence beneath the surface or in hidden pockets of liquid water? Such a discovery would be one of the most profound in human history, proving that we are not alone in the universe. Even if life is not found, studying Proxima B would still yield invaluable insights into planetary formation, atmospheres, and habitability. It would also guide future missions to other exoplanets in nearby systems, each one a new chapter in our search for cosmic neighbors. As we look up at the night sky, Proxima B becomes more than a distant. It becomes a symbol of our curiosity, our resilience, and our drive to explore the unknown. We may be limited by the speed of our ships today, but tomorrow's breakthroughs could open the door to a new era of interstellar discovery. Getting rid of the issue of running out of gas, this is something even more awesome. Cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. For example, the existence of an atmosphere doesn't necessarily ensure that life on Proxima B is present. It could be like Venus, with a thick, hot atmosphere that's inhospitable. Furthermore, get this, the James Webb Telescope can detect such emissions if the planet reaches a brightness of only 5% of the daytime side. Now, 5% may not seem like much, but when dealing with a star that's generally dimmer than our own Sun, it's quite significant. If Proxima B has advanced civilizations, They may use bright orbital mirrors to reflect sunlight from the daytime side to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in a wide variety of sizes, some being gigantic gas giants, while others resemble our own Earth. But what do we really know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Saturn and Jupiter. However, some of these behemoths have been named super-Jupiters. They exceed even the largest planet in our solar system. Yet that's not all. There are also hot gas giants, like Jupiter, which exist extremely close to their host stars, scorching worlds with temperatures that could melt metal. Imagine seeing such a planet up close, with its furious storms and churning gas. In addition to extreme heat giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets frequently remain mysterious due to their difficult atmospheres, which are hard to study from afar. And please, do not ignore the exoplanets that resemble Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, with masses more than twice that of our planet, but still lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is considered a super-Earth, with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b isn't alone, it has a companion, Proxima Centauri c. This planet is much further away from the star, has an orbital period of around 5 Earth years, and was discovered in 2020 using pre-recovery Hubble data. The Proxima Centauri story is intriguing. It appears to be an incredibly bright world, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be known as Proxima Centauri d and would be roughly the same size as Mars or Mercury. Imagine a life where the night sky is filled with stars, as well as countless other planets, each with its own unique characteristics and orbits. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time. While we wait, you can become a space scientist. We don't yet have an accurate count of exoplanets, but we do know they exist, just as we know the stars that light up the night. Exoplanets, on the other hand, are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, as a result of technological advancements, direct imaging of exoplanets is now possible. For a direct image of an exoplanet, it needs to be big enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot enough to be seen from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a fascinating glimpse into the attributes and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. The gravitational pull of an exoplanet can make its host star sway, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a few amusing facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water. Exoplanets with surfaces similar to those in our solar system can also contain natural elements. Satellites known as exomoons may exist. With more than 4,000 discovered exoplanets, we know they exist in abundance. Hot Jupiters, gas giants with immense mass and rapid rotation, are the easiest to locate, but there are countless other exoplanets yet to be discovered. NASA's James Webb Space Telescope is unveiling one of the universe's secrets, one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that will alter our perception of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's formation and composition and gives us a look inside the mysteries of the universe. This gas giant planet revolves around a sun-like star 700 light-years away, and this finding marks a significant step forward in the search for extraterrestrial life. Administrator for NASA, Bill Nelson, stated that this discovery would provide us with a new perspective on the universe that we've never seen before, igniting excitement among scientists and astronomers worldwide. But that's not all. The James Webb Space Telescope has also been busy capturing stunning images and gathering information about the universe in infrared light. One example is the young, emitting object 110 IRAS-4, which illuminates the cool, wispy cloud material. The orange spots behind the cloud reveal light from distant stars, obscured by ice. This remarkable research was part of Webb's Ice Age project, which aims to study the formation of ice, from its creation to the development of icy bodies like comets. Additionally, the James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared.